यार तो अगर प्रॉब्लम है दैट का मैं क्या कर सकता हूँ?
पढ़ना चाहिए
Hello students, so we'll get started in a minute. Here I'm facing a bit of technical challenge. Okay. So just give me a moment and we'll get started. Okay, so welcome to the second lecture on kinematics. So let's get started. Uh, so in the first few minutes, we would do a quick recap of what we studied in the last class, and then obviously we would get going with our today's topic, right? So so this is our second lecture on kinematics, lecture 2, and today we would so in the let us start with the recap of the previous lecture. Okay, so in the previous lecture, first thing we introduced was the concept of rest and motion, and we understood that how nothing in this universe is at absolute rest or absolute motion. Everything is, a relative rest or relative motion, right? So we understood that rest and motion, this concept is relative by nature, and we understood nothing is at absolute rest or motion, right? And for that, we used examples like, a boy named Ram sitting in his room and watching my video. When he feels that the laptop is at rest at him, with respect to him, that is for the fact that with time passing by, the distance of the laptop from RAM does not change or the position does not change. So we established that when position does not change with time in a given frame of reference, we say that the body or the object is at rest. If it changes, then we say that it is in motion. So we established this concept first, and obviously from here we talked about frame of reference, right? And frame of reference, I said that initially we would limit it only to the Cartesian coordinate system where you have your x-axis, y-axis, z-axis, so that any point can be, indicated by its x, y, and z coordinates. Along with position, we would add time as the fourth dimension, and we studied that with the three dimensions of position x, y, z, and the fourth dimension time. Using these four, things, in our frame of reference, we would be studying rest and motion in this chapter. Okay. And then we went over to define some of the physical quantities which would be very handy in the discussion of kinematics. We discussed about distance, we discussed about displacement, and then we understood that rate of change of distance or position with respect to time, right? This as your speed, average speed, and that is where we studied that your average speed is nothing but delta s by delta t, And we also understood that when this delta t or this time interval is very, very small, we say delta s by delta t is derivative of position with respect to time as instantaneous, right? Your instantaneous speed. So when you are doing with position, and obviously if you are doing with a vector, then it would be the instantaneous velocity, and that would be the time derivative of displacement, right? Similarly, after understanding these physical quantities, we moved over to something called as acceleration, right? And acceleration we understood as rate of change of velocity, right? And we discussed that velocity being a vector quantity, it would be undergo a change either if its magnitude is changed or your direction is changed. So your dv by dt, or if you want to say d by dt of v, we studied this as acceleration, which is a vector quantity. So if you want to write it like this, or magnitude would be magnitude of this, right? So we understood these things, these physical quantities in our previous class. We also did two quick practice problems towards the end using the kinematics equations, which we have already studied in our high school level, right? So this is where we stopped our last class. Okay. So, in today's class, we would start with solving one or two practice problems to better understand, the concept of distance displacement and, average speed and velocity. And then we would move on to solving the kinematics equation, and then we would introduce, your motion in one dimension. Okay, so let's get going. So let us start by solving one practice problem so that we understand what we studied about the physical quantities in our last class. And the problem is, so let's say this is our practice question one, and practice question one says uh, a runner a runner completes completes one full round of a circular track of radius 210-meter in 5 minutes. Okay, in 5 minutes. Fine. So the question is, first one, find is find the distance traversed. Second is find his displacement. Okay, and third one is find his average speed, and fourth one, find average velocity. Okay, I would give a few seconds for students to solve, and then we would start solving it on the board. So I repeat, a runner completes one full round of a circular track of radius 210 meter in 5 minutes. Find A, the distance traversed, B, his net displacement, C, find the average speed, and D, find average velocity. Okay, so students, for students who are obviously in class 11th and new to, intermediate physics. So remember, many times, your physics problems would be describing a real life scenario. Okay, uh, every time you would probably not be given, that in a formulae there are four variables, so three would be given, and you just find out the fourth one. Things would be not written that straightforward. So all that we need to do, interpret the practical problem, if required draw a diagram, right, and then start putting those variables, and then find out which formula probably would be suitable. So let's start with that approach. Okay, fair enough. So this is the problem that we need to solve. So let's get going. So what all are given to me in this problem? Okay. So first thing is he is traversing in a circular track. Okay. So yeah, let me draw it. Okay. So say, and I am not great in drawing, so you need to excuse me for that. So say, and students, in our linear kinematics, we would treat every moving body as a point particle only. Okay, in our translatory motion, we would be considering, the movement of the body as a combination of different particles. But in our kinematics, whatever be the size of the body, we would be considering as if a single point is moving. Okay, okay, yeah. So now he started from here. Assume that this distance is how much? 210 meters. So this is given in the problem, right? So this is 210 meter. Okay, and it says that it traversed in 5 minutes, right? So, and it is asking me what is the distance that it covered. So it started from point A, went to this circular track. Say, let me draw just three more intermediate point B, C, and D, right? And he started from here, went like this all the way, and came back to the same point, right? So what would be the distance? Obviously, it would be the circumference of this track, right? So let us find out what would be. So here R equals to 210 meter. So obviously the distance traversed would be the circumference of your this circle, that is nothing but 2 pi r, right? And assuming or taking the pi value of 22 by 7. Okay, assume that in the problem it's given pi equals to 22 by 7, right? So let us put that in this formula. Okay, so 2 pi is 22 by 7, radius is 210, everything is in the same unit, so I don't need to do unit conversion. So this cancels out, this becomes 30, right? So obviously now this would be 2 into 2 into 22 is 44, 44 into 3 is 132, 10, this much, right? So, and what is the unit? Unit would be meter. So obviously in physics you are not you would not be excused if you miss out on the unit, right? Because obviously a physical only 1320, this would have been the incomplete representation. So never forget to indicate the correct unit. Okay, now, so we understood that. So this is nothing but my distance traveled or distance traversed. Okay, this is good. So I have solved the first point of the problem, right? Second one is displacement. So let us go through our initial definition of displacement. And we have studied our first class that displacement is nothing but the change of position with respect, sorry, change of position, right? So if the runner started from here, came back to this point, right? So initial position of initial coordinates was this, final coordinates is also this. So can I say that displacement is nothing but zero, or your magnitude of displacement would be zero because it would be a null vector. I started at point A, he ran The entire track came back to point A. So total displacement is zero. If total displacement is zero and distance traversed is 1320 meter, so obviously very easily we can find out the next two physical quantities that it is asking. So what would be the average speed? So average speed would be nothing but my what is the formula for that? This is nothing but distance divide total distance traversed by total time, right? So what is the total distance? It's just 1320, right? So I would put 1320 here. I would divide it by 5. So this would be your yeah. So is it, should I divide it by 5? No, right? So you need to be attentive. So that's why I said units are important. If you see, this is in meter. So this is in your MKS unit. This one is given as 5 minutes. So I cannot divide it like this, right? So I need to convert 5 minutes into its MKS equivalent. So in MKS system, time is measured in terms of second, right? So that is why I need to convert 5 minutes into its second equivalent. So it will be 5 into 60. So which will be nothing but 300. So this is your 1320 by 300. So we can cancel 10, we can cancel 10. If we divide by 10, 3, this will be 10. And this one, if we divide, then this will be 3 4s are 12, again 3 4s are 12. So 44 by 10, that is nothing but 4.4. And what will be the unit? Meter per second. Don't just stop at 4.4. If you just write 4.4, if you just write 4.4, obviously that's wrong. Yeah, that's that's correct. That's correct, Kusufa. Yeah, that's good. Yeah. Okay. So this is how we find the average speed. And remember, there's a reason why I have given it in different units, just to draw your attention that while solving the problem, you need to ensure that your numericals are all in the same unit. You can convert everything into MKS, CGS, or whatever, but unit must be the same. Okay, and this is why we have studied unit dimension structure. Now, let us go to average velocity. Now, who can type down what will be the average velocity in the chat box? Yes, that's correct, Puspa. Yeah, that's correct. So, what would be the average velocity? What would be the average velocity? So, average velocity would be net displacement by total time, and we know displacement in this scenario is zero by time, that is 300 second, is obviously zero. So obviously zero by anything in the world would be zero. So yes, that's correct. So obviously average velocity would be zero only. Okay, that's fine. Good. So now let us make a small tweak to this problem, and we would calculate the same things, right? And same physical quantities. Okay. So let me just make one small tweak in this problem. Okay. Uh, so I'm saying a runner completes rather than saying one foot. Okay. So this is all there, right? So I'm saying find your distance, displacement, your average speed, and average velocity, right? When he would have traversed half of the circular track. Okay, so I would give you few seconds to obviously do it. Okay, and then I will start it on the board, and I would use that time to sip a bit of water. Okay, let's get going. Okay, and I appreciate students you solving problems real time alongside me. I know that you would solve in home, but solving here obviously has multiple benefits. You would be more attentive in the class, and obviously if there is anything we can discuss, and we can sort it out, right? So same diagram, right? So this is point A, this was point B, this I have denoted as point C, and this one I have denoted as point D, right? So the problem says this guy starts from here and he has traversed the entire thing. That's fine. But we are interested to find out when he moved from, when he would have traveled half the circle, right? So he would have been where? He would have been at point C. So he started from here, okay, and now he is at point C. So when he moved from A to C, we want to find out everything else, right? So we will go the same path, okay? So your radius is given as 210 meter, okay? So obviously what would be the distance traversed? Distance traversed would be half of the perimeter of this circle. So rather than saying 2 pi r, I can say distance traversed here would be pi r. So that is nothing but 22 by 7 into 210. That is nothing but, this becomes 30. So obviously this becomes 660 meter, right? Right? Yeah. So good. So this is 660 meter is the distance. Okay. If distance is 660 meter, what would be the displacement? Okay. So and again in physics, first thing is let us just apply what we have studied and our common sense step by step. Most of the times we would get the solutions, and obviously with passage of time you can increase your speed and all. Okay. So in the interest of everyone's benefit, I would go step by step in the class. Okay. So we know displacement is nothing but change of position, right? So the theory of displacement says this is the final point, this was the initial point, join the final point and initial point, and draw a vector sign from initial to final. I repeat, join the initial and final point, draw a straight line, and draw a vector sign from initial point to the final point, right? So in this scenario, what will be the displacement? Obviously, it will be the diameter d of the circle, right? So if r equal to 210 meter, what will be the displacement? So the displacement's magnitude, the displacement magnitude, right? This would be nothing but 2 times r. So that is nothing but 2 into 210. That is nothing but your 420 meter, right? But if someone writes 420 meter, is it the complete answer? The answer is no. The answer is no. Why? Because of the very simple reason, it has asked you what is the displacement, and displacement is a vector quantity. So while expressing a vector quantity, if you just put up the magnitude, obviously you would lose some mark in your exam, right? You also need to indicate the direction. Okay. So to indicate the directions, you can choose either ways, right? So if you choose this as your horizontal x and y axis, right? So 0 x axis, y axis, right? So you can say displacement would be 210 meter along positive y axis, considering this defined frame of reference, right? So if we define this orthogonal frame of reference like this, and this is how he has moved, then we will say that displacement is along the positive y-axis. Someone can choose this as x-axis, someone can choose this as y-axis, and he or she can say it is, towards the positive y-axis and considering this as frame of reference. So that is why in the first class we have studied that choice of frame of reference is left to the observer, right? And then whatever you have chosen, you should go ahead along with that and express everything in terms of that, right? So you should maintain the uniformity. Okay. So now this is the thing. So if we have found this out, then obviously next to physical quantities would be very easy. I would just start it here and I would leave the arithmetic to you. So the average speed will be nothing but delta distance, or I'll say just a distance delta s by delta t, that is nothing but distance was how much? 660 meter. 660 by time. If it took 5 minutes for the entire track, he would have taken how much? 2.5 minutes for the half of the track. So 2.5 into 60, right? Whatever you get, that is the average speed. I'm not going to solve this last part of the arithmetic because it's simple multiplication and division. Okay, that is on you to solve it. Now let us move on to average velocity. Okay, here your average velocity would again be how much? Your 420 by time was again 2.5 into 60. Whatever you get, this much meter per second. So let me say this is x meter per second, and again you should put the direction that this is along the positive y or positive x if we consider this as that corresponding direction. Okay, so students, I believe this would have given you a little more clarity on how the physical quantities which we studied in our last class are connected. So let's get going into the next topic. Okay, so now let us understand let us understand motion motion in one dimension, two dimensions, and three dimensions. Okay, and after this we would study motion in one dimension today. 2D and 3D we would park it for the next class. 3D is not too much expected in your class 11th and 12th course, so I would just introduce the concept of it, and I would help you finding out how you can, if you understand 1D, how you can easily go into 2D and 3D. That we would talk in our next class, but we would talk a little more extensively on 2D, but not too much on 3D. Okay, so for example, a runner starts from a particular point. He runs on a straight track. Okay, and if we define this as our positive x-axis, this is our positive y-axis. Okay, and this is our positive z-axis. So if you see initially his coordinates would have been his coordinates would have been x1, y1, z1, t1, right? From where time t was t equals to t1. Okay. From time t equals to t1, he has gone up to time t equals to t2. Okay. And I need to draw it as a very straight graph. Okay. So if he has moved in a perfect straight line, right? Then at time t equals to t2, can I say that it would be x2? But if you see, he has not traversed at all along the y-axis. So which means the y coordinate would continue to be y1. Okay, and he has not traversed anywhere. He has come out of the plane and moved in 3D. No, right? We're saying he moved in a very straight track, right? So the z coordinate would also be z1, and time obviously is now t2. The position time coordinates we have indicated, right? So if you see here, when the change of position can be expressed only as change in one direction or one dimension, That is something which we say motion in one dimension, or sometimes we say it as linear motion or linear kinematics, whatever we want to deal with that. Okay, so or motion in a straight line, whatever you want to call. So this is your motion in one dimension. Now assume our runner who went on a circular track. Okay, in his case, if you see, right, so initially this was his x, y, and z coordinates, right? So it could have been, say, something x1, y1, z1 at a time t. When he went from here to here, if you see, his x coordinate has changed, his y coordinate has also changed, right? So that is why it would be at a time t2, it would be x2, y2, z1, T2. And if he would have, started jumping up and down and all those things, then probably Z coordinate would have also come into picture, which we are intentionally not, considering here. Okay. So X2, Y2, Z1, and T2. In this situation, we will call it motion in two dimension, right? So when we are normally when we move on the roads, right? So what it would be? So say I start from my home, I will go to buy grocery and come back. So my motion will be motion in 1D, 2D, or 3D. Type down your answer quickly in the chat box. I started from my home. I and assume I stay in the ground floor. I started from my home. I went to the grocery supermarket and I brought grocery from my home. So did I move in one dimension, two dimension, or three dimension? Yes, it would be two dimensions only because I would have gone, maybe I started from my home, probably would have gone straight, then little like this, then like this, then like this, whatever, and would have come back to my home. So I would have, so throughout my journey, I have traveled only in, the XY plane of the road. And here I'm neglecting that, suppose if my road was an incline up, down and all that I have neglected in this example. Now if I put that into picture, right, suppose I stay in the fifth floor of an apartment. If I stay in the fifth floor of an apartment, I take a lift, I go down, and then if I move on the road, come back to my home, then I have moved across in x-axis, y-axis, and z-axis as well. So in that scenario, my movement would be called a motion in three dimension. Okay, and one more small example to understand motion in three dimension would be, let us consider this as your positive x-axis, this as your positive y-axis, and assume a perpendicular from here outward as your z-axis. Okay, if this is my Cartesian coordinate system which I'm using as a frame of reference, and then if I move my pen like this, if you see, when I'm moving my pen like this, my pen is traversing, its position across x-axis has changed, its position across y-axis has changed, and its position across the z-axis has also changed. So in that scenario, it would be called as motion in three dimension. So when you are, so accordingly, you can find it out, right? So yeah. Okay, let's keep moving. And as I said, for the rest of the discussion today, we will be only talking about motion in one dimension. Okay. Now, for motion in one dimension, for motion in one dimension, we know that a rate of change of displacement is nothing but velocity, right? And rate of change of velocity is your acceleration, right? So we can say v is nothing but your ds by dt, right? And acceleration is nothing but change in velocity by dt. So we are going with the instantaneous one. Okay, here we are not considering the average one. Okay, that's why I use the derivative formula. Now, if this is true, to study our motion in one dimension, obviously, if velocity keeps changing and the rate at which it is changing, it could be constant, it could be varying also, right? So throughout our motion in one dimension, we would consider that your acceleration A is constant. So this is one important thing, students. So you should notice that if A is not constant, then yes. So one example of A being constant would be acceleration due to gravity. When we are considering for motions, very close to Earth's surface, it is considered to be, a constant, but it is not 100% constant. But yes, it is considered to be constant. Okay. So in motion in one dimension, we will assume A equals to constant both in magnitude and in direction, without which all your kinematics equations in one dimension would be failed. Okay. So in high school level, you had studied these kinematics equations. Okay, which is nothing but V equals to U plus 80, right? You had studied S equals to UT plus half 80 square. You had also studied V square equals to U square plus 2AS, right? Where U is the initial velocity. Okay, what does it mean? When your motion started, what was the velocity, right? Or your velocity at time t equals to 0. V is nothing but your final velocity, and which is nothing but velocity at time t equals to anything t. So after some time, what is the velocity, right? And we are saying A in this equation is nothing but acceleration. Okay, and we are assuming that acceleration is constant. See, sometimes acceleration can be zero also, because zero is also a constant, but need not always be zero. It could have some value, but that magnitude of acceleration, right? So if you see, the rate of change of velocity is constant. So velocity is changing, but the rate at which it is changing per time, that is constant. Okay, and S is nothing but your total displacement. Displacement or distance in this equation? Yes, it is displacement. It's not distance. Okay. Yeah. So these are the three kinematic equations we have studied in our high school. So let us see the derivations of them. We'll derive them here. Okay. So let us first see how do we derive them using calculus. Okay. So let's start with, okay. So can I say that A is nothing but dv by dt, right? So we know that acceleration is defined as the rate of change of velocity with time. Okay. So if this is true, can I say A dt is nothing but the small velocity dv? And if this is true, can I say that integration of this and integration of this, right? And now let us put the limits, right? So we said we are starting from time t equals to 0, and we are going till time t equals to t. So my lower limit will be of time will be 0, upper limit of time is t. For velocity, what was the lower limit? What was the velocity, or what was the notation that we have used to denote velocity when it started? We had used initial velocity as u, right? So initially velocity was u, because this is what we said, initial velocity. Okay. From u, what was at time t equals to t? What was the velocity? V. This we have denoted as our final velocity, right? If this is the final velocity, now I have said that the kinematics equations in one dimension will be failed if your acceleration a is not constant. Now, if a is constant, we have studied in our basic derivative and integrations required for class 11 and 12 physics that if there is a constant, there's a function f of x and it is integrated on dx, then we can say that this constant would go out of integration and it will be constant into f of x dx. Okay, so we'll continue with that. If a is a constant, a goes out integration of dt from 0 to t, and you can write the argument as a is a constant, right? That is equals to dv from u to v. Okay, now it becomes a very simple integration. So, and we would use this formula, right? Your integration of x to the power n dx is nothing but x to the power n plus 1 by n plus 1, right? So we would just use that formula to solve it further. Now, using this formula, obviously it would be a stays like this. So nothing into dt. What does it mean? So t to the so it is so can I say that this is nothing but t to the power 0 into dt, right? So t to the power 0, the anything to the power 0 is 1. So dt is nothing but 1 into dt. So I can say t to the power 0 into dt. So let us go still step by step. T to the power 0 dt from 0 to t equals to integration dv from u to v. Okay. So that is nothing but, okay, here also I can say v to the power 0 dv. Okay. So which I can say a into t to the power 0 plus 1 by 0 plus 1 equals to v to the power 0 plus 1 by 0 plus 1, and we would continue the limits. The limits here were lower limit was u, upper limit was v, and here lower limit was 0, upper limit was t. Now, and this a was outside. Okay, so obviously it has become a t from 0 to t equals to v from 0 to u to v. So now, and we know how to put the limits, right? A into, we need to put it first in this function, then minus the lower limit, right? So it would be t minus 0 equals to v minus u. Okay, so that is nothing but at equals to v minus u, or can we say v equals to u plus at, right? So as I am doing as most as few of the students may not be already comfortable in integration, so that's why I've done step by step. In the next couple of directions, we would skip the very basic steps and move on to and jump few steps. Okay, so let's go ahead for the next derivation. Okay, so next derivation we will do. Okay, so here let us consider v equals to, we can say, ds by dt, right? Because we know velocity is rate of change of displacement. Okay, so can I say that, which means v dt will be equals to ds. I can integrate both the sides. This side, your variable for integration is time. So lower limit of time was t equals to 0. upper limit of time was t, right? Your lower limit of your what displacement was 0. It started with 0 and it would have gone to some displacement s, right? So here again, as your v is constant, I would take v out of the equation and I'll do dt 0 to t. So students, I hope you are not sleeping. And if you are not sleeping, you should have opposed me saying, sir, V is not constant here. Okay. So sometimes, obviously, I intentionally do a couple of mistakes to check whether my students are active or they are sleeping. Okay. So obviously, V is not constant here. The assumption was acceleration is constant. So don't mug it up that anything that is with your integration you will take out of the integration. Don't mug it up, take it out of the integration sign only when there is a constant. Okay, so intentionally I was doing wrong here. Now can I say, now v is not expressed in terms of time, right? So one of the fundamental thing that we use throughout our physics is, if we have f of x and dy integration, remember students, our formulae are defined for f of x dx. If this is a different variable and this is a different variable, you cannot use your integration formula directly. So the mathematical modeling that we need to use there is, you need to express this one as a converted function of variable y only. So which means I need to express v as a converted function of dt. So any equation that I need, that I know related to v, I should not use. I should use an equation where I can convert v as a function of time. So can I say that in the first equation we have learned v equals to u plus at. Okay, this much into dt from time 0 to t. Okay, equals to ds from 0 to s. And you can write the counter argument here as v equals to u plus at from your first kinematic equation. Okay. Now, we know that in integration, when there are two functions, you can put them as you can separate those integrations. So I can say it 0 to t u dt plus at dt from 0 to t, that is nothing but equals to integration of ds from 0 to s, right? Now, if that is correct, then let's go to next step. Okay, so here in the next step, I can take u out of this integration, u integration of dt from 0 to t plus acceleration a is constant, a goes out of the integration, t dt from 0 to t equals to ds integration 0 to s. Now again, if students are not sleeping, they would have said me, sir, you cannot take u out of the integration sign. No, this is correct, because obviously the initial velocity had got some defined value, right? That is not changing. The based on the acceleration, your final velocity is changing. So had it been v dt, I could have not taken v out of the integration sign, because initial velocity was already predefined, right? So the motion started at a particular velocity. Okay, so that is why you can comfortably take u out of the equation. This is not incorrect. This is correct, and this is right. Okay, so and let us understand the reason. Let's not mug it up. Okay, now which means this is u integration of dt is t from 0 to t plus a, here it would be t square by 2 from 0 to t equals to s from 0 to s. Now just put the values u t minus 0, that is nothing but ut equals to, sorry, plus a t square by 2 equals to s minus 0 is s. So can I say that S equals to ut plus half at squared, right? So we proved the second kinematics equation, S equals to ut plus half at squared, okay? So this is good. Now, let's move on. Let's keep moving. And now we will prove the third kinetic equation. Just give me a moment. Now we'll prove the third kinetic equation. So again, we'll start with A equals to dv by dt. Okay. So can I say that now can I say that A equals to dv by ds into ds by dt. So students who are new to derivative and integration, don't think that it is like it was x by y and I multiply and I put it like this: x by a into a by y. No, this is not right. Intentionally, I'm not explaining you how this is happening, but this can be done in derivatives, okay? Because I don't want to introduce that concept of mathematics here. But yes, as per mathematical operation, this is correct. But don't think that it was x by y and I have multiplied the same value in numerator and denominator. Because remember, students, dy by dx, this is not equal to dy divided by, it is not dy divided by dx. It is rather a function, a derivative function d by dx of y, and y must be a function of x, right? So it is not, had it been the division, then dt would have got cancelled and it would have been just y by x, okay? So it's not a your regular division here, okay? But as per derivative operations, this can be done. I understand that with the limitations of this scope of this class, I cannot explain you this theory right now. But so this one thing you probably have to remember for now. Okay, when you go into that chapter in mathematics, it will be very clear to you. Okay, so so I can say that A equals to dv by ds. Do we know that ds by dt, this is nothing but v? So I can say v ds, I'll put v in place of your ds by dt. So I can write that a ds is nothing but v dv, and if that is correct, then I can put integration sign on both sides. So here I'm integrating with variable s, which if the lower limit was 0, higher limit is s. Here I'm integrating by velocity. Its lower limit was u, upper limit was v. Okay, okay. So let's keep going. Okay, so now let's do the integration of this. So this is here. A is constant. I can take it out of the integration sign. A integration of ds from 0 to s is nothing but. Can I take this v out of the integration sign? No, because if you see the variable is dv. If v were the variable, you would have not got a differential with this same thing, right? So v will not go out. Okay. So this is v to the power 1 dv. So integration of v dv from u to v. So that means a s minus 0, because integration of ds will be s, okay, is nothing but, here it will be v square by 2, the lower limit is u, upper limit is v. Now I can just put those values there. So as is nothing but, first it will be v squared by 2 minus u squared by 2. So can I say, if 2 goes common in the denominator, can I say that this is v squared minus u squared by 2, and this is v square minus u square by 2. Can I say v square equals to, I'll multiply these two here, right? So can I say u square plus 2as, this becomes your equation 2 for equation number 3. Okay. Okay, yeah. So this becomes the equation proof for equation number 3, right? So now let's do one thing. So I have derived these using the calculus method. I have proved these equations. Okay. I would give one small home task to you, that prove prove S equals to ut plus half at squared using graphical method. Okay, and when I'm saying graphical method, in the first class we have seen, the expressions, using the graphs, right? So I'll just give you one small hint, that use the velocity time graph. Okay, using the velocity time graph, try to prove s equals to ut plus half at squared. Okay, and remember students, we have studied one concept when we were studying the basic use of derivatives and integration physics, that throughout your physics, your rate rate of change of something is always found out as a derivative, right? And suppose if you have any curve, the entire area under that curve, okay, the for finding out the area under the curve, we do integration in our physics, right? So I'm giving you this hint. Using this hint, try to prove it yourself. If not, we'll see in the first few minutes of tomorrow's class. Okay. Now let us go into some practice problems. Okay. So, and in these practice problems, we will, as I said, we are concentrating on motion in one dimension, and we will do some quick practice problems. So I have noted down some practice problems. So let us try to solve them. Okay. So the first one is two balls, one of mass 2 kilo, and second one is of mass 5 kilo, are dropped from a tower of height height 490 meter. Okay, find find the time, or find after how much time they would hit the ground. Okay, and find out what would be their speed when they hit the ground. Okay, or we can also say what will be their velocity. This can indicate the direction also, right? What will be their velocity when they hit the ground? Okay. So in the interest of time, I would start solving it in few seconds. You can just give the initial thought, and as I said, again, a practical scenario is given to you. Try to draw a diagram. I know that probably you could have mug up couple of formulae in your high school, and you can solve it in 2 seconds. But before going into that formula, I want to introduce a small concept here. So that is why I want you to draw the diagram and try to do it yourself. And we'll start it. Okay, let's see how we'll solve it. Okay, and we will introduce two concepts here. Okay, so I said we have a tower. We have a tower of height 490 meter. Okay, Mr. Einstein was standing on this tower. Okay, and Mr. Einstein, and assume that it there are two stones here. Okay, one was here, one was here. This is the ground. This is how we indicate ground in physics, right? With this kind of notation. This one having mass 2 kilo. This one was having mass 5 kilo. Okay, and he dropped both of them, and the height is 490 meter, and he is dropping it from here. Okay, now in this physics problem, let us first consider this first ball of mass 2 kilo. Okay, so what all are given? So when I am saying it is dropped, if I am saying it is dropped, then can I say that the initial velocity u was 0, right? So that is given. Okay, what else is given? S is given, the displacement. He dropped it from here, and it would have, and it has hit ground, right? So the displacement is given as S equals to 490 meter. What is asked to me? What would be the time, right? And at what velocity it will hit the ground? So direction, I would know that obviously it would be, directly 90-degree on the ground. Okay, yeah. We know that in reality it will not be 90 degrees because of Earth's rotation. That's fine, but we can still say that it will hit the ground vertically. Okay, okay. Because if we consider Earth's rotation, your kinematics problems, your kinematics, these equations will not be valid, because then we will enter into a non-inertial frame of reference. Okay. So here, if we see now in your high school level. Okay, okay. So now let us solve it. Okay. So if we want to solve it, then can I say that S S equals to UT plus half AT squared. Okay, and here A is equals to G, which we can take as 9.8 meter per second square. It is not given, but we know G equal to 9.8 meter per second square. There could be few problems where they would have explicitly asked you that use A equals to 10 meter per second square, but if not, then you can always take G equals to 9.8 meter per second square, right? So in that scenario, how would I solve it, right? So I know that what is the value of S? That is 490 meter per second. Sorry, 490 ut. U is equal to 0, so this becomes 0, right? Half A is nothing but 9.8 and time square, right? So here I can say that t square equals to 2 into 490, right? So it will be 2 into 490 by 9.8 and the root over of that, right? So this would be your 980 by 9.8 root over, which is root over of 100, which is nothing but equal to 10 second. So this thing we have seen in our high school studies, right? And we have also seen a formula that when something is dropped, we had studied this at scenario one, that if something is dropped from a height, right? We had studied a formula. If it is dropped, then it would be S equals to ut is 0 equals to half gt square, or we have studied the formula that t equals to 2, rather than saying s, that time we used to call it as h. So we have studied a formula t equals to 2h, sorry, yeah, 2h by g root over. We had mugged up this formula and we used to use it, right? And we had also we are saying that whenever something is thrown down, take it as plus gt square.
Whenever something is thrown up, take g equals to your minus g. Now, in our first class, we have introduced something called frame of reference, right? In high school, the reason why they had said is, for solving this problem, they have taken this as your frame of reference. Okay, so they have taken this as the origin. This may be your positive x or y, whatever you want to call. If this is your positive x, and this one probably they have taken your positive y axis. And as I said, you choice of frame of reference is completely left to you. You can choose this as positive x axis also, sorry, or positive y axis, positive x axis, positive z axis, whatever you want to say. Okay, so if I choose this direction as the positive, then we need to put the sign in this equation accordingly. Similarly, we'll go to another problem and we'll see when it is thrown up, right? So when it is dropped, your u had no value. When it is dropped, u had no value. So obviously it didn't have any direction, right? Your acceleration here is g, that is downwards. So in this convention, downwards is positive. So that's why you can continue using, plus half gt square. Okay, your displacement, this is along this direction. So that is why s will also be positive. Okay, and v is also in this direction. So v, that's why will also be positive. Okay, so that is why you can also rewrite these equations as, here s will be equals to s positive, u positive, t is positive, right? So ut plus half g t square, because it was dropped, so u becomes 0. So that's why you will finally remove it, and you can directly say your s, or if you want to put it as height, h equal to half gt square. This is what we had done in our uh, high school studies, right? And one more interesting thing, if you notice, here t is a function of your height, or s, whatever you want to say, or s and g. So g is also constant. So it is fundamentally a function of your height, right? It is not a function of mass. Okay, so this thing obviously is given in your physics problem to confuse you whether you'll drop a 2 kg ball or a 5 kg ball or a 500 kilo ball, right? They would hit ground at the same time. Okay, similarly we'll see, will they hit the ground with the same velocity or not. Now here you can give an argument that, sir, when I drop a feather, right, it takes a much longer time to hit the ground versus when I'm dropping a piece of stone. Obviously the difference is, here in this problem we have not taken the air resistance into calculation. Okay, but in real life there is no place for assumptions, right? You need to consider all the real life reasons, right? So that is why when you are dropping a feather versus a stone, a feather would get much higher, your air resistance. So it will, so we are, both the bodies are, coming in air. So feather would have higher air resistance. So for that, it will be difficult for it to, freely move under gravity. Okay, so that is the reason why you would see a difference. Okay, but here we have taken g as constant, and we are assuming that no air resistance is in this case. Okay, cool. Now let us quickly find out what would be the velocity at which it will hit the ground. Again, for velocity, u is positive, your g is positive, and let's do one thing. Let us solve this problem by taking our original convention, right? So if we take this as the positive axis and this as the positive y-axis. Suppose this is your positive x-axis, this is positive y-axis, this is origin. So in this problem, what could have happened? So we know our initial kinematics formula is s equals to ut plus half at squared. Okay, now let us start putting the sign. Okay, so if this is my positive y-axis, okay, what will be the sign of displacement? Displacement started from here and it came up to here. So obviously the direction is minus. So I will say minus s equals to u is 0. So this part completely gets cancelled out. In this scenario, this becomes 0. Okay, plus half. We can't change the sign of a scalar. Okay, then a acceleration. Acceleration due to gravity is downwards. So can I say that this is nothing but minus g? Time is again a scalar. It does not have a sign. So I'll just keep it like this, which also means this minus and this minus will get cancelled out, and it will be s equals to half gt squared. So you need not mud it up that when it is when you drop something and you are considering the downward journey, put everything as plus, and when it is upward, put everything as minus. Don't mug up that formula. Okay, just put the signs, and obviously once you practice 4 5 problems, these will be very easy and very obvious to you. Okay, now let us apply this to solve our next formula, and intentionally we would use the other dimensions, or the other frame of reference. Okay, so I will take everything that is coming. So in this frame of reference, this is my positive x-axis, this is my positive y-axis. Now I want to find out v. Okay, so in this also v also is downwards, so sign for v will also be minus, right? So v equals to u plus at. This is my basic kinematics equation. Okay, so here now let's start putting the sign here. V here is along the negative axis, so I'll put minus v equals to u is nothing but 0 in this case, so I need not put anything for that. A here is acceleration due to gravity, that is also in the negative direction of my convention, so I'll say this is minus g into t. So obviously this minus sign and this minus sign will cancel out, and again it will be v equals to gt. So I know g, I have got the value of t in the previous direction, so I will put it just here. So that is nothing but g is 9.8 into t is 10, so that is nothing but 98 meter per second. Again, don't forget the unit. Okay, 98 meter per second. As it is asked velocity, we'll say vertically downwards. Okay, vertically downwards. Or if you have chosen this as your frame of reference, then you can say minus 98 meter per second. So obviously anyone in physics will understand that this is the frame of reference, and this student has chosen this as the negative axis. Okay, now let us go to one more problem. Let us go to next practice problem. Okay, and next practice problem reads okay, yeah, an arrow, your PQ3, an arrow hits hits the trunk of a tree. So suppose this is a very big tree. Okay, an arrow was coming from the side. Okay, and it hits it here. Okay, an arrow hits the trunk of a tree at a speed of 1 moment. So uh, yeah, arrow hits a tree of a tree and penetrates 0.4 meter. Okay, so this is traveling at a speed of 16 meter per second. An arrow traveling at a speed of 16 meter per second hits a tree trunk and moves in by this much of distance, and this is given as 0.4 meter. Okay, and it is asking that find find the time taken before before the arrow came to rest. Okay, so obviously if an arrow or a bullet is, or this can call it, you can change as a bullet, or you can say a pin is hitting a wall and it penetrated a bit, and you want to find out the time. Okay, so here also let's do the same thing. Let us define a frame of reference. Okay, I have defined this as my frame of reference. If this is my frame of reference, my u was along this direction, so I'll say positive u. Okay, okay. Now, why in the earth it would have stopped after 0.4 meter? Because because obviously the tree trunk would give it some, a position, right? And we assume that it has retarded at a uniform retardation, and it has come to stop. So the assumption here is your retardation or your deceleration is uniform in this case. Okay, okay. So if there's a retardation or if there is a deceleration, so the deceleration would be along this direction or this direction. Obviously it will be along this direction, not along this direction. So if it is along this direction, then can I say my a is along this direction? So can I say it has positive a? No, because my convention is this is positive, and obviously then this will be negative, so it will be negative a. Okay, now it started from here and you went to till here. So this is my displacement of s vector, right? So displacement is again this direction. So it will be positive s. It is not negative s, right? So now final velocity v. If it has come to rest, then obviously final velocity's magnitude is zero, which means direction you can give arbitrary, so it is inconsequential, and I will say v equals to zero because it has come to rest. Now obviously start putting it here. U is given, u is 16 meter per second, right? Your s is given as 0.4 meter. V is given as, or you can interpret that V equals to 0. So obviously we can use the formula V square equals to U square plus 2AS. Again, I'm saying don't mug up that in case of acceleration, put it as plus, in case of deceleration, put it as minus. Okay, see, that is why we are using frame of reference. We will automatically come here. Okay, so V is 0, nothing, I'll put 0. U was in positive direction or negative direction? Positive only. So I need not change anything. U squared plus 2 A. A is plus, A is having plus sign or minus sign here. It is getting the minus sign because my frame of reference is like this, right? So it would be minus A. S. S has also got positive sign, so I would not change it. So I will say S. So can I say that here 2as equals to u square, because this will be minus 2as. You can take it to this side, and this will be 2as equals to u square. If that is that, then can I say that that means your a equals to u square by 2a, sorry, by 2s, which would be nothing but your a equals to u squared. So 16 into 16 by 2 into what it was, 0.4. 2 into 0.4, let me put 4 by 10. If it's 4 by 10, 10 will go to the numerator. So 4, it will be 4, right? And if I divide it, this will be 2, this will be 8. 8 into 4, 32 into 10, that is nothing but again 320 meter per second square. Okay, this is the retardation, or finally we have found the magnitude. Okay, now if I have found it out, now I can put V equals to U plus 80. This is my formula. Again, V is 0, no need to put the sign. U is positive direction, plus A is minus A into T, that is nothing but your AT equals to u, or t equals to u by a. So u was 16 by 320. Obviously, it becomes 0.05 meter, sorry, 0.05 second, right? That's it. Okay. Now, in next 1 minute, I'll quickly show you how I can solve this problem by completely reversing the frame of reference. Okay. So suppose one student took this as, okay. So let me not rub it so that you would not lose the reference. So suppose one more student chose this as the frame of reference. Okay. So here, for him, what it would be? So initial formula was v square equals to u square plus 2as. Okay. So v is 0, no need to put any sign. U, u's direction is not changing because when you are changing the frame of reference, your actual things are not changing. Your conventions will change, right? So in this scenario, now this is positive direction. So can I say that u, which is in this direction, it will now be minus u, right? Again, your acceleration is in this direction. So acceleration is now along the positive direction. So now acceleration will be positive. Your displacement, that is displacement is in this direction, and this your convention is positive and this side. So now this will be minus s. Okay. So if we put it in that equation, we would arrive at the same place. So if you see, here it would be u square, right? So u square and then your 2a, and it will be rather than s, it will be minus s. Why it will be u square? Because square of anything is, your positive. It will not change, right? So that's why it will be again nothing but 2as equals to u square, and then it becomes the same, a equals to u square by 2s, and you will get the same values. Similarly, when you would put here v is 0, u u is now minus u, so now this will be minus u plus 80. A here now is in the positive direction, so it is like this. So obviously your ut will go to this side, so it will be nothing but your minus ut. When it will come to this side, it will obviously be ut, sorry, it will be plus u only, not t. U equals to 80, the same thing, which is nothing but t equals to u by a, and you will get the same answer. So no need to bug up this students. Okay, we'll do probably one last problem, okay, for the day, and we'll stop it there. Okay, and there could be many interesting things here, right? That when you